0 to any integer, as a result what you are getting, again you are getting the same number. Okay, so that's why this is called as what? Additive identity. For example, see, if I consider a is equal to 2, what is 2 plus 0? 2 only. Therefore 0 is called as additive identity with respect to this operation, addition. Okay, suppose if I consider a is equal to minus 5. Now see here, minus 5 plus 0, what is the output of this one? Minus 5 only. See, whatever the number that you choose here, and if you add this with 0, what you got? Minus 5 only. Huh? Let me consider one more example here. Suppose if I consider 0. 0 only if you consider. What is 0 plus 0? 0. 0 only. Okay. So for any integer a, 0 is called as additive identity. Why? Because a plus 0 is equal to a. Okay. Now, if you consider, let me take one more example. B is equal to minus 3 here. Okay. B is equal to minus 3. What is b plus 0? B. B plus 0, B. Okay, we'll verify. What is the value of B here? 3. Minus 3. Minus 3 plus this is 0. Minus 3 plus 0 is how much? Minus 3. Minus 3. So we got the same. Correct? That's why 0 is called as what? Additive identity. Next, multiplicative identity. See, this 0 is the additive identity. Okay, with respect to which operation? Addition operation. Now, similarly, we have something what is called as multiplicative identity. That is what? With respect to multiplication. Now tell me, which is the multiplicative one? 1. Why? Because if we multiply 1 with any number, number will be same. Number will be same. Okay, see, how to define that one? Suppose if you consider a is an any integer. Okay, a is an any integer means it could be any number from this collection. Okay, instead of considering some specific number, generally I am considering a is an any integer. A could be 1, it could be 2, it could be minus 100, minus 10, minus whatever it may be. A, what? But a is what? A is an integer. Okay, so once you go to higher classes, how they are writing this one in the mathematical format, they will write like this: a belongs to what? Z. The meaning of this notation or symbol is that a is a member of Z. Z, we know what is Z. Z is the collection of integers. Okay, this symbol is nothing but this is epsilon. Okay, we use this one because we know that once if you use this notation, this means a is an element of Z. Okay, see, 1 is an element of Z. Correct? Is this true or false? Tell me. True. Because 1 is an integer and Z is what? Z is the collection of integers. 1 belongs to what? Z. Similarly, what about this one? Is it true or false? True. True. This is true. What about this one? True. True. What about this one? True. False. True. False. Why this is false? Yeah, because 1 by 2 is not an integer. So this is the false statement. Correct? Now see. Suppose if you consider a is an any integer. Okay. If you consider a is an any integer, then we say that 1 is the multiplicative identity of the element a or integer a. Why? Why? Because if you multiply a with 1 as an output, what you are getting? A. Again you are getting the same number. For example, see here, if I consider 1, what is 1 into 1? 1 only. Therefore, 1 is called as multiplicative identity. Similarly, if I consider 2, now we will verify this term. 2 into 1 is how much? 2. 2 into 1 is, again it is 2. Therefore, 1 is the multiplicative identity. Similarly, if I consider a is equal to minus 5, a is equal to minus 5, then minus 5 into 1 is how much? Minus 5. So 1 is the multiplicative identity. Correct? Because minus 5 into 1 is what? Minus 5. What happens if I consider 0? 0 into 1 is how much? 0. 0 into 1 is 0. So here you took a is equal to 0 and as an output you got 0 only. Right? So this is called as what? Multiplicative identity. Is it clear? 1 by 2 is not a member of Z. Such examples are also there. But the main problem arises because of denominator being 0. If you consider B as 0, okay, A by B, if B b is equal to 0. Because of this problem only we said that a division of two integers is not an integer. What happens? See, if the numerator becomes 0, there is no problem at all. Okay. Suppose if I consider a is equal to 0 and b is equal to 3. What is 0 by 3? 0 by 3 is 0.3. No.
Anything 0 by anything is 0 ma.
0 by anything is what? 0. What about this one? 0 by 5. 0 point. This is also not 0.5.
0 by anything is
0 by anything is 0. Okay. Now my question is that suppose if a is some number. Okay. Suppose if I switch. If I consider a is equal to 3 and b is equal to 0, what happens here? What is 0 by 3? 0 by 3? Now what is the value of this one? This is very interesting one. We'll take this whenever some number is there in the left hand side. If it comes to the right hand side, what happens? Division into the product multiply. Okay, 3 into 0. When you shift this 0 to right hand side, it will become what? Multiplication. What is the product of 3 into 0? 3. Hey, 3 into 0 is how much? 0. 3 equal to 0. Is it true? 3 and 0 are the same. Then, so if you said 3, no, that's why this problem came. 0. If you consider 0, instead of 3, you will get 0 here. 0 into 0 is again 0. See, 3 and 0 both are not same. They are different. Then what is the value of this one? It will be division of a number by 0. Contradiction. This is a contradiction, no? Any doubts? This is contradiction. Why? Hey, no. See, 3 and 0, are they same or different? They are different. No. Why you are getting this kind of contradiction? Because here you assume 3 by 0 is equal to some number. So if you assume and proceed, you will get a contradiction. See, basically what happens? 0. Division of a number by 0 is not defined. Why it is not defined? Because of this reason only. Okay. What about 0 by 0? So all these are very important critical situations that arise constantly. Such situations will arise in number system while studying the number system. What is the value of 0 by 0? Tell me. 0. Huh? 0. Are you sure? Zero by 0 is indeterminate. Indeterminate. There are two forms. That is not assume 0 by 0 is equal to some integer. Why? Because we know that 0 is an integer. 0 is also an integer here in the denominator. Suppose if I assume that 0 by 0 is some integer, see what happens? 0 is equal to a into 0. Here, this a is not some specific exact number. Even you can choose 1 here. Then also the result is true. 1 into 0 is 0 only. In place of a, even if you take 2, then also it is 0. Even if you take 3, then also it is 0. Even if you take 4, then also it is 0. So that's why we are not finding some value. See, whenever you are dividing something, the number as an output what you are getting, that is specific. For example, if you consider 10 by 2, 5, this is constant. Okay, apart from 5, it is not possible for us to write anything here. Okay, but here if you write 1, still the equation balances. Okay, suppose if you consider this 2, now also this balances. Suppose if you consider 0 by 0 as 3, then also it balances. This comes in number theory. Okay, as you this kind of situation will come in number theory.
Akshay, doubt,
indeterminate.
Doubt.
Huh? This is indeterminate. Hey, is it clear? See, if you divide 10 by 2, here whatever the number that you are getting, that is fixed. You can't change this one. But here what happens? Even if you assume 3, this equation balances. Even instead of 3, even if you assume 10, then also this balances. See here, because 10 into 0 is what? 0 only. That's why this is indeterminate. Clear? This is the one more important point here. So division of a becomes 0. A becomes 0. See here. If a becomes 0, there is no problem because 0 by anything is always 0. Okay? 0 by anything is always 0.